Hello everyone, my name is Muneeza Fatima and my college roll number is 225054 and my topic for discussion is dual space, contravariant tensor, covariant tensor and mixed tensor. Vector space, a non-empty set V over field F with two operations, vector addition and vector multiplication, is said to be a vector space if it satisfies the following properties. V comma plus is an abelian group and 1 comma alpha is equals to F alpha for every alpha belongs to V, and C1 C2 dot alpha is equals to C1 bracket में C2 alpha will for every alpha belongs to V and C1 C2 belongs to F. And my fourth property is C alpha plus beta is equals to C alpha plus C beta for every alpha beta belongs to alpha comma beta belongs to V and C belongs to F. And fifth property is C1 plus C2 and bracket close alpha is equals to C1 alpha plus C2 alpha for every C1 C2 belongs to F and alpha belongs to V. And vector space is denoted by VF basis. A non-empty set S of V is said to be basis of V if S is linearly independent and S spans V, that is alpha belongs to V, then there exists C1 C2 C3 up to Cn belongs to F such that alpha is equals to C1 alpha 1 plus C2 alpha 2 up to Cn alpha n, where S is alpha 1 comma alpha 2 up to alpha n. So number of element in S is k upon a dimensions of V. Change of basis. If E subscript I and E subscript I dash are two bases of vector space V, if E subscript I dash belongs to V and E subscript I is its basis, then every element of E subscript I dash are in linear combination of E subscript I. So E subscript I dash is equals to P superscript I and subscript I dash E subscript I, where P superscript I and subscript I dash is n comma n non-singular matrix there such that E subscript I dash is equals to P superscript I and subscript I dash E subscript I. E subscript I dash is equals to P subscript I dash and superscript 1 E1 plus P square I dash dot E2 plus up to Pn I dash is into En. So I dash is equals to 1 2 3 up to In. So similarly we can write the basis E I dash E subscript I is equals to P superscript I dash and subscript I into E I dash subscript I dash, but we can balance it. What is contravariant vector? Let VR is a vector space over field of real number if M belongs to V and C infinity belongs to M, denoted the set of all differentiable functions in neighborhood of M. Let tangent vector f lambda at M such that lambda C infinity M belongs to R is a function satisfying the following properties. For every f comma g there belongs to C infinity and alpha and lambda bracket में f plus g bracket close is equals to lambda f plus lambda g and lambda bracket f g bracket close lambda g plus fm plus gm plus lambda f and lambda a bracket af bracket close and a lambda f. Let mm be the set of all tangents vectors lambda comma mu at M. We define two operations on mm. lambda plus mu operated on f is equals to lambda f plus mu f, and a lambda operated on f gives a lambda f. For every lambda comma mu belongs to mm and f belongs to c infinity m, and lambda m belongs to mm and a belongs to r and f belongs to c infinity m, then ff form a vector space over field of real number r with respect to operations defined above, and this space is called space of contravariant vectors, and elements of mm are covariant vectors. So now what is law of transformation? Let mm star be the space of covariant vector e sub superscript I and e superscript I dash are two bases of mm star. Let mu belongs to mm star and mu I and mu subscript I and mu subscript I dash are components of mu with respect to basis e superscript I and e superscript I dash respectively. So we can write mu subscript I dash is equals to p dummy index I and I and subscript I dash is equals to mu subscript I. It is the law of transformation of covariant vectors. Now what is dual space? Let f be n-dimensional vector whose vectors are contravariant vectors. Let v star be another vector space associated with v whose vectors are k upon a covariant vectors. Let us define a real valued linear function v mappings are such that mu operated on a lambda plus b mu is equals to a mu lambda plus b mu mu. For every lambda comma mu belongs to v and a comma b belongs to r and mu belongs to vector space v star, then vector mu of v star is k upon a covariant vector, then addition and scalar multiplication of v star is defined by v lambda is equals to alpha lambda plus beta lambda, and a operated on alpha lambda is equals to a alpha lambda, where alpha, beta and mu belongs to v star and a belongs to r and lambda belongs to v. With these operations, v star form a vector space k upon a dual space of v. The basis for this dual space is k upon a dual spaces of b. Now change of dual spaces. Let v be a vector space with basis e subscript I and e subscript I dash with dual spaces e superscript I and e superscript I dash, then e superscript I dash is equals to p dummy index I dash and subscript I is e superscript I. Contravariant and covariant tensor. Let a superscript I where I is equals to 1 2 3 up to n be a function of a coordinate x की power 1 comma x square comma x cube comma x की power 4 up to xn of the quantities a की power superscript I are transferred to another coordinate system x dash 1 x dash की power 1 comma x dash square comma x dash cube up to x dash n. According to law of transformation rule, we can write a dash superscript I is equals to a superscript alpha del x dash superscript I upon del x del x superscript alpha. Then the function a superscript I are called components of contravariant tensor. Now let a subscript ij where ij is equals to 1 2 3 up to n be a function of a coordinate x1 comma x2 comma x3 up to xn of the quantities a subscript I are transferred to another coordinate system x dash comma x 2 dash comma x dash n. According to law of transformation, we write a dash subscript ij is equals to a subscript a alpha beta delta x superscript alpha upon delta x dash superscript I multiplied by delta x superscript beta upon delta x delta x dash superscript j. Then the function of subscript ij are components of covariant tensor. Mixed tensor. If n square function a superscript I and subscript j, where I comma j is equals to 1 dot 2 dot 3 up to n of the coordinate x superscript I be transferred to a dash superscript I and subscript j in another coordinate system x dash superscript I, according to law of transformation rule, a dash superscript I and subscript j is equal to a superscript alpha and subscript beta del x dash superscript I and del x superscript alpha up into del x superscript beta upon del x dash superscript j. Then a superscript I and subscript j are said to be the component of mixed tensor of rank 2.